In the today's session, we are going to cover structure, difference and application, nested structure, and self-referential structure. So these are the outlines. So first we will be covering difference and application of a structure, then nested structure, and then self-referential structure. So now let's see the example for definition and declaration. So when we are saying structure definition, here struct card. So in this structure card, we have the two member functions. One is the face and one is the suit. And both of them are pointer variables, means face is a string and suit is also a can be used as a string, right? Second is your declaration. In the declaration, we have said that we have created an object that is the a card deck, that is a array of structure of 52 which can hold the 52 element of struct card type, and there is a pointer variable card ptr which can point to the structure of type struct card. Accessing the structure member. So there are two ways to access the structure member. The first one is the dot operator and the second one is your arrow operator, right? So I have explained in the previous session that where we should use the dot operator and where we can use the arrow operator. So let's see the one example. Let's say there is a one structure card and it has the two member function. One is the face and other one is the suit, which is a pointer to a character, and that can be utilized as a string, right? So what we have done is we have declared a struct card, a card, and we have initialized the two value to the a card. That is, the first value is 3 and the second value is the hertz. So a card dot face will be 3 and a card dot suit will be hertz. So we have two more object of this structure. One is the DAC 52, that is the array of structure, and second one is the card PTR, that is the pointer to the structure. So what we have done is we have fetched the address of a card structure and we have stored the value of that address in a card PTR, right? Because card PTR is a of type pointer type, right? So now what I am trying to explain you here is the where you can use the dot operator and where you can use the array operator. So the first structure, that is the a card, it is a simple type of a structure. So if you want to access the value of any member of a card, then you can use the dot operator over there. For example, if I want to access that what is the value in the a card dot face or a card dot suit, so I will simply write a card dot suit, right? So a card dot suit, it will return the value hertz because suit is the second member, so second value is hertz, right? And if I want to access the value from the card ptr, so card ptr is a pointer, so but it is pointing to the same structure, that is a card. So if I want to access the member of that one using this card ptr variable, that is the pointer variable, then I have to use the arrow operator over here. So I have to write card ptr arrow suit. So what it will be doing, it will be accessing the value of the member function which is stored at this particular address location. So it will also return you the display the hertz. So this is the program which we have done in the last class also. So this is just to explain you that how the things are we can access using the dot operator and the your arrow operator, right? So in this we have a structure, a struct card, face and suit, the same one which we have covered in the last slide. Then you have struct int void main void, right? Struct card, a card, struct card star card ptr, right? So a card dot face is ace and a card dot suit is spades, right? So again what we have done is we have copied the address of a card into the card ptr. So again, if you want to access the card ptr face, then we have to use, because card ptr is your pointer variable, so we have to use the arrow operator. And if you want to use a card suit dot suit, then it is a actually normal structure variable, so you have to use the dot one. So that way you can access the members of a structure. Now structure applications. Structure allow to store different data type information inside it at continuous memory location, right? It is collection of different data type which are at continuous memory location. So what we want to tell you here with these 2 points is that what happens is that many a time we want to store the information in a continuous memory location, but that information is not of the same type. For example, if it is a record of a student, then name is different data type and roll number is different data type and age may be the different data type and marks may be the different data type, but I want to store it continuously, so I cannot do that thing using the array. So what we have to do in that case, we have to use the structure. If you want to represent too many information, too many variable of same data type as a single entry, then we go for array. But if you want to represent too many information, too many variable of different data type, then what we have to do is we have to go for the structure. So this is the application of the structure, right? Now coming to the nested structure. Nested structure means a structure inside the another structure, right? A structure can be nested inside another structure. In other words, the member of a structure can be of any other type including structure. Here is the syntax to create nested structure. So let's see the 2 examples over here. Struct address. So in the address you have city, you have pin, you have phone, right? And you have a structure called employee. So now we are telling 2 things here, that in the struct employee we have the name, and what we want is in that struct employee I want the address of the person also. So what we can do is, in spite of writing all the information about the address, what we can do is we can use the already defined structure address in this particular structure, right? So this is the one way of doing it. The other way of doing the same thing is, suppose you have the struct employee, right? This is the same as struct employee, name, your character type array, name, and then in spite of writing struct address add, what we can do is we can define here the one more structure, and that is of the same type as it was. So you can use either this method or you can use this method. Both the method are of gives the same thing. So structure are derived data type. They are constructed using object of another type. So consider the following structure definition. Struct card, char face and char suit, both of them are of pointer type, which can be utilized as string, right? Keyword struct uses the structure definition. The identifier card is the structure tag, which names the structure definition and is used with the keyword struct to declare variable of structure type, right? This thing we have covered in the last session also in details. Now accessing the nested structure members, that how we can access the member of a structure. As I explained you in the previous slides also, that there are 2 way of accessing the member of a structure. That is, the one is the dot and the other one is the arrow one. So we are for now we are considering this dot one only, because I just want to explain you that how to access a member of a structure in which the structure is nested. So let's say struct student, and inside that we have the structure person. In that person we have name, age and date of birth, and we are saying the object of this particular structure is P, right? And there are 2 more things associated with the student, that is the roll number and that is the floating point variable marks, and we are creating an object struct for this. So suppose if I want to access the name of the person, so and that is from the struct student. So object of this struct student is stu, and in this stu we are trying to access the uh, structure P, because the object of this struct person is P. So we'll write struct P, and in the P we want to access the name. So this one we will write like this. So it will be struct.p.name, right? Same way, if you want to access the age, then again stu and inside that there is a P object, and in the P object we have the age, right? The same way for DOB, date of birth. So this is how we can do it. But suppose if I want to access the roll number, then what we will do simply is that is struct dot roll number. we can access this one directly. Now, important point, nesting of structure within itself is not allowed. For example, struct citizen, and then you are writing char name, char address, int age, int SSN. Then you cannot write a struct citizen inside this. Got this? Because then what will happen? Then struct citizen inside struct citizen, then it is going to be the infinite nesting, right? Because this struct citizen will again contain the struct citizen, and this way. So this way of doing it is invalid. So you cannot define the same structure inside that particular structure. Now coming to the initializing nested structure, that how we can initialize the value if the structure are nested. So suppose you have the structure person, then we have name, age and date of birth, and we have the struct student. In that we are using this struct person. So struct person info. So int, roll number and float marks. This is same as the example which we have done in the last slide, right? So now suppose I want to initialize the value at the compile time. So what we can do is, so we have struct student, student one, right? So this we are talking about this particular structure, right? So what is the first information? First information is struct person info, and info will contain the three things, that is name, age and date of birth. So we will write in the curly braces name, so that name will go to this name, and then age will go to the second parameter, and then date of birth will go to the third parameter. Then after that, this particular first thing is complete now, right? Now then you have the roll number, so simply we will write the roll number here. Then the third thing is the marks, then we will write here the marks, that is 90, right? So this is how we can do the initialize the nested structure at the compile time. Now let's try to understand the nesting of the structure using a program, right? So hash include stdio.h struct person, and the person will have the three fields, that is the name, age and date of birth. Then struct student. In the struct student, the first thing that we have, that is the struct person info, right? And then that is student roll number and that is student marks. So coming to the main program, int main struct student s1. So s1 is declared a variable of type struct student, right? So now just we are printing details of student. Printf enter name. So where the enter name should go? The enter name should go to the s1 dot info dot name, right? So s1 dot info dot name. Second is the age. So age is also s1 dot info dot age. So address of s1 dot info dot age. The third one is date of birth we want to access. So s1 dot info dot date of birth. Now the next one is your roll number. So roll number is just inside the struct student. So s1 dot roll number, and the next one is marks. So s1 dot marks, right? So if you want to print all this information, then simply we are writing printf name percentage s1 info dot name, then s1 info dot age, s1 info dot date of birth, s1 dot roll number and s1 dot marks, right? And then return 0, which is generally used to signal to operating system program that everything ran fine. The simple output will be naturally it will print the name, whatever you will give as the input. Suppose these are the actually inputs here. Detail of student, enter name, we have entered Amit, enter age, we have entered 27, then date of birth we have entered this way, right? Roll number this and marks this. So finally it will give you the output like this. Now, self-referential structure, right? So self-referential structure are those structure that have one or more pointer which points to the same type of structure as their member. So now you have to understand the one difference between the nesting the same structure within itself, which I told you that is invalid. But here what we are doing is struct node, and in the struct node what we are saying is struct node star link. So if you write here struct node inside this struct node, then it is invalid, right? Because struct node cannot be inside the struct node. But here what we are saying is, we are saying that we have the structure like this, right? In which we have few fields in that one. Suppose let's say the first one is data. So this value will come here, right? Then you have the data 2, that value will come here. And what we are saying is the third value is a pointer actually, which will store the address, and that address will be of what type? That address will be of struct node structure type. So what we are not doing here is, we are not defining here the complete structure. We are just reserving one space to store the address of the struct node type structure. Got this point? So this is called the self-referential structure. Why it is used? It is used that suppose if you have one more structure of the same type, then what we do is, suppose this is also a struct node and this is also a struct node, and this is about the information about the student. So what we can say, suppose this is for student A, right, and this is for student B. So what if I want to access after student A, I want to access student B. So what we will do is, whatever the address of this particular structure will be, right, that value I will store in this one. So what we can do is, after accessing this particular structure, we will go to this particular address, and at this particular address, this structure B will be there, where all the data related to the student B will be is stored. So we can access with the help of this one. So int main struct node OB return 0. Now to help us understand and think about self-referential structure, we use this picture. So first you have data, as I explained you in the previous one, the data member, and here you have the pointer member. What it stores? It stores the address of another structure which may be of the same type. Same type means, if I take the record of two students, let's say there are two students A and B, then naturally the record of the both the student will be same. The structure of that both the records will be same. The value may be different. So what we can do is, we will call it that that is the structure of same type. So in the first structure, what we are doing, we are just simply storing the address of the second structure. So let's see one example. Struct list in data struct list next. So we have a structure and we name it list, right? We have a structure, we name it list. In the first field, it is data, right? And in the second field, we have the struct list next. So name of this is next, right? And it can store the address of similar kind of a list. Suppose there is one more list, this. So naturally it will also contain, the first field will contain the data. Naturally the value will be different. Suppose say that value of this one is A. Okay, so this is int. So let's say the value of this one is 1 and the value of this one is 2, right? So what we can say, but what we can store in this one, we can store in this one the address of this particular node. So let's see here, struct list ABC, A dot data is equal to 1, B dot data is equal to 2, right? So this is A and this is B. So data of A is 1 and data of 2 is 2, and let's say there is one more, that is C, and data of C is, let's say 3, right? So A dot next is equal to B dot next is equal to C dot next. So in the starting, everywhere that is null, null. In the starting it is null, in the starting it is null. So this is how we are initializing in the starting. But later on what we can do is, we can, in this field, in place of n, we can put the address of this one, and in the place of this null we can put the address of this one. So what will happen? So we can sequentially access the structure or record one after the another one, right? So this is shown over here. The first one is A, its value is null. Second one is B, their value is 2, and the C, the value is 3, and we have in the starting we have put the null in that, and this is how we can do that. That in the initially it do not contain any data. So after that, what we can do is, we can store in the A next. A next means this second field of A, we can address store the address of B. So we can find the address of B by using this particular operator. So that value will go in this A, and we can write the value of B next is this one. The value of this is address of C. So we can find the address of C using the this special operator address, and that value can be stored in this. Now we can use the links to retrieve data from successive element. So we can, if you want to access all the elements, suppose this list is very long, so we can access the data after A node. We can go to the B by using this address. Then at B we can use access this node using the address of C, and so on. So linear linked list, a linked list has a header pointer that addresses the first element of the list. Then the pointer member in each structure is the list pointer to the successor structure. The last structure has its pointer member set to null. Typically a linked list is created dynamically. So what we want to tell you here is that what is linked list. So this kind of a structure is called linked list, that you have one structure, you have another structure, you have one more structure of, and all these structure are of same type, right? And like that. And so what is happening, this one contains the address of this one, 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 and the last one contains the null, right? Last one contains the null. So this is called the linear list, that you can access the list one after the another one. So it contains the data, and it has the one last field, that is your address of which can is a pointer which can store the address of same kind of list. So that is called your linear linked list. This you will study in the second year in the data structure subject in the details. So these are the references from where we have created this PPT. We have taken the data from the following resources. And this is my mail ID. If you have any query, you can write on this mail. Thank you very much. Thank you.